In previous lessons, you estimated probabilities of events by collecting data empirically or by establishing a theoretical probability model. There are real problems for which those methods may be difficult or not practical to use. Simulation is a procedure that will allow you to answer questions about real problems by running experiments that closely resemble the real situation. It is often important to know that the probabilities of real-life events may not have known theoretical probabilities. Scientists, engineers, and mathematicians design simulations to answer questions that involve topics such as diseases, water flow, climate change, or functions of an engine. Results from the simulations are used to estimate probabilities that help researchers understand problems and provide possible solutions to these problems. Our first example. How likely is it that a family with 3 children has all boys or all girls? Let's assume that a child is equally likely to be a boy or a girl. Instead of observing the results of actual births, a toss of a fair coin could be used to simulate a birth. If the toss results in heads, H, then we could say a boy was born. If the toss results in tails, T, then we could say a girl was born. If the coin is fair, for meaning the heads and tails are equally likely, then getting a boy or a girl is equally likely. So when we create a simulation, there are 5 steps that we need to keep in mind. So let's list out our 5 steps. So our first step is to define the basic outcome. So define basic outcome. This is meaning, so for example, we're going for this problem, we're defining an outcome of a birth. Our second step is to choose a device to use and define which possible outcomes on the device represent an outcome of the experiment. So choose a device to use and define which possible outcomes on the device represent an outcome of the experiment. So for example, we could say that we're going to toss a coin, and that if we get heads, it will be a boy. Heads will be boy. Okay. Our third step is to define what is meant by a trial in the real experiment. So for example, 3 tosses represent 3 births. Okay. Our fourth step is to define what a success is. Define what a success is. So for example, if we want 2 boys in 3 births, heads, tails would be a success. Okay, and our last step is to perform a number of trials. And if you remember back to when we talked about the relative frequencies of heads and tails in lesson 8, we talked about the more trials we have, the better trials, or the better the data is. So the more the better. So for this, we're going to count the number of successes, and then we're going to divide that number by the number of trials. Okay, so let's go over a couple more examples here. So we're going to still use the example of births. So how could a number cube be used to simulate getting a boy or a girl? So there are a lot of different options. A couple of options. Our first one could be if we use the numbers 1 through 3 to represent a boy, and then we could use 4 through 6 to represent a girl. That way each of our boys and girls have 3 different numbers. We could do odds and evens. So we could do odd is a boy. We could do evens for girls. And there are many more options that you could choose. These are just a couple of examples. And then how could a deck of cards be used to simulate a boy or girl birth? I would do these by color. So in a deck of cards, we have red and black cards. There's 2 suits for each, so the same number of cards. So we could say if we get black, we get a boy birth, and if we have a red, it would be a girl birth.